Hi, I'm Robert Bell from Pathway Connectivity Solutions. We're a manufacturer of lighting entertainment networking gear, such as gateways and switches. And I'm going to talk to you today about what I call the four-letter words of Ethernet networking and how it is relevant to the entertainment industry. And to do that, it's basically leveraging on technology that is easily available to us rather than inventing our own cables and connectors and all the rest of it. And a lot of these standards have been ratified by the IEEE. So how do we take advantage of them and what do they do? So I'm going to start off with this very academic discussion about the open systems interconnection 7 layers of networking. Anyways, on the first layer, it's essentially bits on the wire. It's electrical, and that's kind of like what you would see in a hub. This is a very old-fashioned hub I have, and basically every bit that comes in, one port goes out the other. There's no smarts about it all. And then layer 2 is the data link layer, and this is where you have frames of data. And then going up, and you would see this as layer 2 switches. These are the first switches versus hubs. And then going a little bit further, we go into layer 3. You heard of layer 3 switches, and this is packet management versus just frames. And this is where you can actually start to dissect different protocols and maybe differentiate between something like, say, streaming ACN and ArtNet, or Dante and other high-end upper-level protocols like TCP and HTTP and all the rest of it. And then at the fourth layer, this is the datagram layer, and this is where we do multicast stuff like UDP and TCP, and then above that, everything else is just data and session presentation and application layer. But what we often use is this Wireshark tool that shows these layers in the lower section here. And the physical layer is the NIC, the network interface. And that's just raw bits. And then the data link layer, is node to node communication based on MAC addresses. And then the networking layer is where you'll see the internet protocol. And then on the fourth layer is where you see TCP and UDP, which is our multicast stuff. And then in layer 5, 6, and 7, session presentation and application layers, where you see protocols like HTTP and FTP and SACN and things like that. So moving on, I want to discuss what I like calling the 4-letter words. And some of them are 3, like PoE. But there's PoE, VLAN, IGMP, EAPS, RSTP, LLDP, DHCP, QoS, and then the ordinate Dante, which is a 5-letter word. But I'm going to go through each of these and explain how they might be useful when you are building an entertainment network and how you can leverage on them. So let's just get right into it. The first one has become quite popular in the last 20 years. It's called Power over Ethernet. And this is very similar to how data has been transmitted for condenser microphones. We call this phantom power, but rather than being on an analog signal, we would actually do it with, the digital signal. And we always see this with Cat5, Cat6, Cat7 cables. And there's a common voltage that is applied to the data pair and then pulled off at a center tap. So because there is the data is differential, data plus, data minus, any of you who are into DMX would understand that. It doesn't matter if you add voltage to that or take it down from it, because you're always looking at the bits between what's difference between data minus and data plus. So then you can apply voltage and then pull it off the center tap. And then with gigabit, we actually use all 8 wires to apply voltage. And there's different standards. There's the AF standard, which is up to 15 watts, about 12, 13 watts at the power device. And then the AT standard, which gives you up to 30 watts. Most of our products work with the 15 watts. That's still quite a lot of juice for a DMX gateway or an IP phone or a audio interface. They're not needing 30 watts. And then there's there's PoE plus, which is going up to 60 watts. So if you wanted to do lighting or something like that and put a bunch of sensors in it. But it's really handy because you can have data and power down one wire. You don't need an additional, wall wart or IEC cable giving power with a switching power supply in these small devices. And one of the really cool things, if you have a clever managed switch, you can remotely reboot devices, give them a cold reboot just by removing PoE and then reapplying PoE. And that can be very useful when you have a large network of stuff spread out over a building and you just want to give things a reboot at midnight. So the next four-letter word is virtual local area networks. And this is kind of fun. My little demonstration of it here kind of is like, okay, in one piece of hardware, you have, 3 nodes that are talking and another 3 nodes. Now, I'm going to show a little example here. Wouldn't it be nice if every department chose their own color of Cat5 cable? But the color alone is not going to differentiate data. But as we are building theaters now and production environments where almost everything is being transported down Cat5 or Ethernet, you don't want crosstalk between departments. So a typical example here would be a switch, and you might have this thing at the FOH, and then you might have at the stage, you might have this other switch, and you want to bridge different things, different devices. Well, you wouldn't tie these 2 switches together, but maybe my example is not showing devices, but if you had, say, the audio working in this department and lighting working over here, then things like their IP pools would be conflated, or even their data might be conflated. So what you can do is you can separate out the switch to have a VLAN, which is these 4 ports, and these 4 ports, and then have, these 6 ports as, say, the video VLAN. And then what you need to do is tie them together, and we like to do this with 10 gigabit Ethernet. So therefore you can have lots of connections from the front of house to the stage going down a single tagged port. That's where you see one of the ports. This one would be on the back of these switches, a tagged port. And then when they get to their location, you would have the audio here and the video here, or the lighting here. You could break it down to as many as you would like. So there's a quick explanation of VLANs. The next one is Internet Group Management Protocol. And this is the ability for the switch to do what it does best. And it's to reduce the traffic on these different links. So what you have is you have end devices here, like this guy A wanting to talk some protocol to another guy who's interested in A. And then this querier here in the middle is actually aware that this guy is interested in this guy's data, and it will then do this rather than sending it out to everybody. So this is what switches do best. And to do it, you need to enable an IGMP querier, somebody somewhere in the network. It doesn't have to be in the middle. Networks are networks. And then every other switch has to snoop and say, oh, this guy's interested in this packet versus all the other data that's on the network. So this is a cool little example where we took a gateway, a theatrical console speaking into a switch, and the switch speaking into the gateway. The gateway has 2 DMX ports, and the top one is feeding the top, and this guy here is feeding the bottom. And what happens when we get to about 44 universes is we filled that pipe right here. And data was clogged because it had to transmit all of the data down the wire. But when we turn on IGMP, you can see that the pipe that goes from the switch to this small device is only getting universe 1 and universe 44, and therefore there's lots of space in the pipe for it to move. The next one is rapid spanning tree protocol. And this is a method of determining when a accidental loop is made. And those guys in audio, and you've seen it with video too, where you get feedback. And I could tell you I've made this mistake myself where I plugged in too many of the spare redundant wires that go from the stage to the FOH, and you end up getting a loop. So basically this node speaks to this one to speaks to this one, and it comes back to this one and he hears himself, and it comes back through this one and he hears himself. So the rapid spanning tree protocol can basically prevent the ugly feedback that you would see when you make a loop and it just grinds your network to a halt. Now, a more managed version of redundancy protection and adding loops is Ethernet automatic protection switching. And this is where you intentionally, but by using a bit of management, create a loop. So if data needs to get from A to B, typically it might route this way. But what happens if we break this? With EAPS, everybody is aware of which direction the data is going. And if this gets broken, data will automatically be rerouted this way. And what's really cool about EAPS is because you actually say what are the primary ports and what are the secondary ports, you can heal this in less than a DMX frame. So we have a little video that I did years ago where I had a controller on a table talking to a gateway which was feeding DMX to a light which was doing something very, very pretty on the stage. And I just plugged in this switch. So obviously the data was going this way the first go around. But as I walk around the table, and again, remember the data is going this way, if I walked around the table and I took and I snipped the wires as I do here, you see the light doesn't change and the data automatically routes and goes this way around. So another one of my favorite protocols is this guy here. It's called the Link Layer Discovery Protocol. And it's essentially, although it works at layer 2, I say it helps you identify gear that is plugged into a device at layer 1. So if you're looking at a switch, and it might even have VLANs where your management VLAN is on one, but all of the multiple other ports are on a different VLAN, you can't see that traffic. But you can ask the port, hey, whose product is attached to me here? And this is really helpful after you build your network. And over the years, things might be plugged and replugged in different locations, but you can still build a network map to see what's plugged in where. And that's really useful when you have the ability to reboot devices using that PoE we spoke about earlier, because you don't want to accidentally reboot or kill a portion of your network accidentally. So being able to click on a port, know that it is such and such a gateway attached as a node on that port, then you can say, right, let's power cycle that. Or what is he connected to? And then you can go, the knee bone's connected to the leg bone, connected to the hip bone, connected to the backbone. And it's very useful when you can't visually put eyes on your network, kind of like I can here with all of my stuff. The next guy here is called Dynamic Host Configuration Protocol, and everybody's using this even if they don't know it or not. And it's basically what your home router does. So when your friend walks in with their phone to your house, hey, can I get on your Wi-Fi? You can't speak internet protocol until you have an IP address. So your home router will dish out an IP address, and you probably don't even care, but it's likely 192.168.1.x number between 1 and 255. Not 255 though, because that's broadcast. But so there is some gear that is being manufactured now, small little gear that doesn't have any user interface or any dedicated management protocol to get to that first layer, which is like, hi, I'm out here, I need an IP address. So having a switch or a device, a router on your network that can send out DHCP addresses as devices come and leave the network, and then you don't have to manage a big Excel table of all of the IP addresses, static IP addresses of devices that are on your network. And if you're using VLANs, you can have a DHCP server with a different pool of IP addresses for every single network. So I like to think of this as the old operator with the exchange tables. They give a phone number, they connect one phone number to another phone number. They have a lease for a certain amount of time. And then once the lease is up, they pull it out. And if somebody asks for another connection, then they can give you another IP address. So moving on, this guy here is called quality of service. And it's not really a protocol. It's basically a different set of rules. So the switch knows how to manage certain physical connections and certain traffic. Traffic gets tagged, not tagged like VLANs, gets allocated saying, okay, I'm important, I should get there in a certain amount of time. So the idea is to increase the throughput and reduce any jitter so that if you're expecting packets to come at a certain rate, they will come, and if they can't, then the switch will tell you, hey, I'm sorry, I can't make that connection reliably and consistently. And then it can reserve a certain amount of throughput from this port to that port, and then do things like surfing the internet or email at a completely different rate. That stuff's nowhere near as important as a broadcast of audio. So having a network switch that can set up quality of service very quickly, basically you can allocate, okay, these ports are going to become on the superhighway. These guys here, they can get there as long as they get there. That's fine. And then there's other guys that basically are a goat path. And it's like, well, you either get there or you don't. And you got to remember that the whole basis of Ethernet communication is it's potentially unreliable by design. Not TCP reliable transportation, but multicast UDP. Basically, it does its best effort to get data from one port to another, but if the switch gets too busy, it will drop things on the floor. Now, one of the best examples of defining a strict quality of service was done by Audinate, that did the digital audio network through Ethernet. And this is sort of better, an improvement on earlier versions of audio over Ethernet. Dante has higher channel count than CobraNet. And it has lower latency. Its configuration has been pretty much automated by defining strict rules for quality of service. And Dante, unlike CobraNet, has native gigabit support. And it's being used a lot more and more in entertainment networking, because when you do audio multiplexing, kind of like DMX, multiplex data, you can have, one source and then an almost unlimited number of sinks, because the signal does not degradate. You don't need transformers. You don't need power boosters that can inject noise and increase the noise threshold and all the rest of it. So just think of, a high school public address system, which has used to be done analog with a bunch of transformers and high voltage, 70 volts for speakers and stuff like that. Now you just have a network, and kids are surfing the internet on the network. The teachers are getting their lesson plans on the network, all the rest of it. You have, one public address system, and you can have an unlimited number of speakers getting complete clean audio off of it. And there's other advantages to Dante too. One of them being security, which we'll talk about in a moment. And the other advantage Dante has is that that it has a matrix, so you can have all of these sources going out to all of these devices, or basically you can have digital mixers and all the rest of it. Anyway, Audinate's done a great job with Dante, and there's now a whole plethora of devices. This one's particularly cool. It's just a power over Ethernet, and you can plug in a microphone or take that and get the opposite version of this and plug it into a power amp and then distribute over fiber for miles without any signal degradation. So those are the 4-letter words of Ethernet networking. I want to take a little bit of time to look to the future and talk about security. And, in the world where we were building production environments, we had dark networks. And basically the audio guys might have their network with their sound consoles and some of their Dante devices and their iPads where they could mix and all the rest of it. And the lighting guys would have theirs, and the video guys would have theirs, and comms would have theirs. But nowadays in performing arts centers and schools and all the rest of it, basically IT deals with one backbone, and almost every department gets onto that same backbone. And then you have VLANs and other methods of management. But we do need to now talk about security. And why? Well, because there's lots of, we call them bad actors, that are willing to hack things. You hear about security breaches all the time. And a lot of the current lighting all of the current lighting protocols don't have security inherently put into them. As I mentioned, Dante does. But there's a push now in the Control Protocols Working Group to add a layer of authentication or security to standard protocols like E1.31 streaming ACN as an additional layer. Anyways, currently our prime defense is physical access. So, that's easy if you have a very small network and you know the color of your network cables and you know all the empty ports and you disable all the ports that aren't there. But you got to remember, these bad actors might be looking for physical access in a closet. They might plug something in to do something nefarious, or worse yet, with Wi-Fi, it's almost impossible to know. And there's more and more devices we want where we can walk around the theater, like our phones, to do remote focusing or mixing sound or that sort of thing. And there's more and more applications too that are giving World Wide Web access, so for remote management. So doing physical security around your network is becoming more and more difficult because people just come to expect having that sort of access everywhere. And you got to remember, if they can get on your network, they can do pretty benign things like turning your lights off, which would be very embarrassing for you if you're doing a live broadcast. But they might be able to broadcast audio and say things on your speaker system, or they might be able to just randomly go and reboot devices. So what should manufacturers be doing to aid in doing security? So devices must be able to reject modified firmware. Really tricky people, we see this on Windows all the time, replace parts of the operating system with Trojan horses or bots. So any device that can do a firmware upgrade over the IP must be able to reject it if it's not coming from the manufacturer. The other one is they must, if there are downloadable configuration, most people have free tools to configure their devices. You must be able to limit access. I know products in the past basically said, oh yeah, just download our software, connect it up, then you can do any sort of configuration you want and take your laptop away and the device will carry on. Nowadays, you really want to be able to be sure that if somebody does come in, a bad actor comes into the theater, that they can't see your devices with the same tools that you use every day. And then once you have once you have locked down your configuration, you have to make sure that people can't come in and modify it. And this sometimes is not necessarily just a bad actor. Sometimes this is just a technician trying to do the right thing, but maybe unaware of very specific things you've set up. So you might have set up VLANs or port speeds or IP pools or quality of service, and some good thinking technician thinks he might have a better idea of it. You have to be able to control who has access to all of the parameters of your network and make sure that they have authority to do it after you've commissioned the system. And then once you and all humans have gone away with it, there must be this idea of device-to-device authentication, so that the devices on the network working autonomously from humans can see that this is a member of the family per se, and they can this device knows that it is allowed to communicate to this device, so that if you have a lighting console and it needs to talk to a DMX gateway, which will then talk to the lights, you want to make sure that the gateway knows who his controller is. And if another controller comes on, then he should be rejecting the new data coming from the unauthorized controller. And then in the meantime, when these standards haven't been ratified by people like the Control Protocols Working Group at ESTA or what other trade association that writes these standards, in the meantime, you should be able to segregate your network down to its smallest parts. So if you have a network that is mostly secure, and then you want to add a device that isn't secure, you should have a very small section of the network that brings that data onto the network through a gateway or a router with configurable parameters, and maybe encodes and adds the encryption to it. So that's pretty much my time on this. Those are what I call the 4-letter words of networking, and we touched a little bit on network security. So I hope you enjoy the rest of NAMM, and I'll leave it up to my other friends in the Control Protocols Working Group to talk about some other topics. I'm Rob from Pathway Connectivity. Thanks so much, and have a great show.